All right. Unit 9, conics and parametric equations review for the test. Problem number 1. So, write the equation of the ellipse whose vertices are blobbity blobbity and foci are blobbity blobbity in parametric form or rectangular form, and then we want to do some other stuff with them as well. So, although D says to graph the ellipse showing the vertices, covertices, and foci, that's actually where I'm going to start this problem because I think it makes it easier. So I'm going to zoom in here. Let's focus on these vertices and covertices. No axes here drawn in for us, so we will need to draw our own. So let's think about what would make sense. So first thing I'm going to recognize is that every single one of the points given to me has the same y value, which means they are all in line horizontally, which means my ellipse is going to be horizontal. Alrighty, because they're all at that y value of 7. So let's go ahead and draw some axes here. Notice the vertices, -8 to 2. That should tell you how far to the right and how far to the left of the origin you need to go. So let's go ahead and draw some axes in, and we will get started. So I'm going to draw a vertical axis right here going down. And then I am going to draw a horizontal axis. Let's go, I don't know, how about right down here? So let's plot these points. So let's see, y value of 7 is 1, 2, 3, 4, 5, 6, 7. I count on the internet. There we go. There is our y value of 7. Our first vertex has an x value of 2. So over 2 up to that point. 7 right there. There we go. I'm going to go ahead and actually erase that 7. It's probably going to get in the way. Okay, so there is one vertex, coordinates 2, 7. I'm going to go ahead and label that with a V just so I can remember it is a vertex and not a focus. And then the next one has the same y value but an x value of -8. So let's go 8 to the left of the origin. 1, 2, 3, 4, 5, 6, 7, 8, and up to that same y value of 7 to plot that point right there. And again, that is also a vertex. I'm going to label it as such just to help me. Next, I know where the foci are. I can't talk. Where the foci are. One focus has an x-coordinate of 0, and again, it's going to have that same exact y-coordinate of 7. And then my next point is at -6, and I don't even need to count because I can tell that the foci and vertices are 2 apart, so they have to go there because it's going to be the same distance. So there are my 2 foci. And now, directly in the middle of all this jazz, I'm going to have my center. So let's see, between those 2 foci, I have 1, 2, 3, 4, 5, 6 spots, which means the distance from the foci to the center is 3. So I'm going to go 3 from one of those foci to get my center point. Now that's telling me I now have my center. I know the y value is 7, but what's that x value? That x value is -3. So I've identified my center. That is good. What else have I identified in this process? Well, I said that the foci were each 3 away from the center. Well, that's what your value C tells you, the distance away from the center that your foci are. So C equals 3, that value that I found. All right, well, what else can I tell? Well, I also know that the distance from the center, that was my attempt at drawing a C, the distance from the center out to a vertex is your A value, and that distance there is 5. We can see, we've counted it. So A then has to equal 5. So I know A, I know C, which means I can find B, which means we need to call up this lovely little equation for an ellipse specifically. A squared equals B squared plus C squared. So let's figure out what B squared is, which means I need to subtract C squared. So A squared minus C squared will tell me what B squared is. And now let's go ahead and plug in the values that we know. We know A is 5, so I have 25 minus my C value squared, which is 9, equals my b squared value. So 25 minus 9 is a number. 25 minus 10 is 15, so 25 minus 9 is 16, which is telling me b, and therefore, I'm sorry, b squared, and therefore I know that b has to be 4. How else could you have known that? Well, look at what we have here. We have a Pythagorean triple. So you could have also known a 3, 4, 5 triangle right there. But I have A, I have B, which means I can do a couple things. First thing I'm going to do with that B is I'm going to use it to plot my co-vertices. So from my center, I'm going to go down 1, 2, 3, 4. Boom. And I'm going to go up 1, 2, 3, 4. How do I know I'm going up? Well, I already have my points out side to side. So there we go. We know our A value is running horizontal, which means B is running vertically. And I can now sketch in this ellipse. And then I can go ahead and actually write this equation. So let's go ahead and say that x, is it going to be plus or is it going to be minus? Well, notice our center is to the left, which means we need to add x plus 3 over, I guess let's go ahead and square that now, x plus 3 squared, quantity squared, over what? What do we put that over? Well, what is our a value? What is the distance to the vertex there? That a value is 5, so I'm going to write a 5 squared underneath. So x plus 3 quantity squared over 5 squared plus, now my y term, what's it going to be? Well, my center is up 7, so it's going to be y minus 7 squared over, what was that vertical distance we went from the center up? Well, we went up 4, so I'm going to have a 4 squared down there. If you get this far, man, that looks pretty good, but have you actually written the equation of this ellipse? No, because you don't have an equal sign. So let's make sure we say equals 1. There we have the rectangular form of this ellipse. Let's go ahead and transfer this into parametric form as well. So x equals 5 cosine theta minus 3. That was easy. Y equals 4 sine theta plus 7. Take a look at my parametric equation compared to my rectangular equation and notice where all the pieces fit together. So one of the few things left to do, what do we need to do? We need to find the eccentricity as a decimal, no less. So I guess you'll use a calculator for that, but shouldn't need a calculator for anything else. And I think that's it. So remember that the eccentricity is calculated by taking C and dividing it by A. So in this instance, our eccentricity will equal exactly 3 over 5, which is actually nice, and we don't need a calculator to figure out. What is 1/5? Well, 1/5 is 20%, so 0.2. So 3/5 is 60%, so 0.6. And there you have it. We found our eccentricity, and we're super done.